Welcome to part 2 of section 2.3, talking about linear equations. Let's talk more about the slope-intercept form. And here we have a form that is not in slope-intercept form. Actually, it's in standard form. And sometimes, perhaps we remember from Algebra 1, ax plus by equals c as the standard form. And we're going to talk more about this in this section. But that's what the form is now, and we wanted to get the slope-intercept form, which is solving for y, in other words, y equals mx plus b. So let's get this equation in there. First step is to subtract this 5x from both sides to begin isolating y, or getting y by itself. And that's going to leave us with negative 4y and negative 5x plus 16 on the other side. Last step is to divide everything by negative 4 to get y by itself. And let's see here, let's take a look at what that's going to look like. Watch those negatives, and we're going to have positive 16 divided by negative 4. That's going to leave us with negative 4. Now remember, a negative divided by a negative is positive, so to clean this up and make this look pretty, it's going to be y equals 5/4 x minus 4. The next one down here has leading coefficients that are actually fractions, and we can get rid of those here in the process and make this look real pretty. But let's again focus on isolating y. So we're going to go ahead and add 3/4 x to both sides. And we're left with 1/2 y equals 3/4 x minus 1. Last step is to get rid of this 1/2, and you all recall that we're going to multiply by the reciprocal here of 1/2, which is 2/1, and we're going to multiply that on both sides. This is going to simplify to 1y, and let's multiply everything by 2 into this parentheses, and that's going to be 6/4 x minus 2, and simplify 6/4, 2y equals 3/2 x minus 2. So you can see that we went from this standard form up here to this slope-intercept form, and went from standard form here to this slope-intercept form here. On this page, you'll see we've got a couple other problems here where they're asking us to take us from standard form to slope-intercept form. And let's do one more, and then we'll leave the other one up for your Cornell notes. Let's take this one and solve for y here, in other words, slope-intercept form. First step, add 7x. And don't forget that this is going to simplify to 0, and don't forget to bring down that negative. Last step, divide everything by negative 5. And that's going to leave us with y equals negative 7/5 x plus 7. 5 goes into 35 7 times. Again, going to slope-intercept form from the standard form. Let's talk more about graphing. Here are two equations in which they are in standard form. They want us to graph them. One way to graph these is obviously to solve for y. Here we're going to add 2x to both sides and graph. First thing is to look at the y-intercept, which is 1. Go to 1 on your graph, and then do what the slope tells you to do. The slope is telling us to go rise to, run 1. So I'm going to rise to, run 1. Rise to, run 1. Rise to, run 1. And those are all my coordinates. So I'm going to go ahead and draw my handy dandy little line. Just for giggles, we could have also gone down 2 over 1, down 2 over 1, and then down 2 over 1. Again, keeping that linear form. Here is our linear line. And there is our, I'll extend this off a little bit. There's our linear function. Again, all we did was go right to the y-intercept, 1, here, then do what the slope told us to do, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And if you guys recall from the video yesterday, that this is a positive slope. Positive. Sorry. Too bad they don't have spell check on these things. But we can always change that. It's positive. And we've got a positive slope right here, so of course everything is going to be positive. Let's try this one here. First step, subtract 4x from both sides. And we're going to have, drop that negative, 7y equals negative 4x plus 14. Divide everything by negative 7. When I mean everything, I mean everything. This is going to simplify to just 1y. Positive 4/7 x. And 14 divided by negative 7 leaves us with negative 2. Just like the last problem, we're going to go start off at the y-intercept, which in this case is negative 2. So I'm going to go to negative 2, make my point, and from there, do what the slope tells us to do. Go up 4 over 7. So I'm going to go up 4 over 7. I also could have gone down 4 and to the left 7. And there is our linear function. Again, solved for y, went to the y-intercept, then from there, did what the slope told us to do, go up 4 spaces over 7. Or we could have gone down 4 over 7. I wanted to finish off a couple ideas about standard form. And we got a nice little definition here for standard form in of a linear equation. This would be a great note for your Cornell notes. And also, if you can, I know you can, go ahead and write this whole problem out in your Cornell notes. And we're going to go ahead and solve or get this in standard form using integer coefficients. Now that we've got that written down, let's take a look. We are going in reverse of what we were doing just before. The idea is that we want to get x and y on the same side of the equation. They're both on the left here. Here's one's on the left, this one's on the right. We need to get them all over on the left and all the constants on the right-hand side. Remember that C is going to stand for constant. So our first step, subtract 3/4 x from both sides. And then they asked us to go ahead and use integer coefficients. In other words, they want us to get rid of this fraction. One way to get rid of a fraction is to multiply by the reciprocal. However, if we multiply this by 4/3, we're going to have 4/3 here in front of the y, so we've got a little bit of a quandary. In other words, we're a little bit confused here. But I also know that if I multiply everything by 4, that will cancel out with this denominator of 4. So I'm going to multiply the whole shooting match by 4. And by the whole shooting match, I mean the whole shooting match. Put a reminder over here, put a reminder over here, and multiply 4 all the way through this side and 4 on the right side. This 4 is going to cancel with this 4. That's going to leave us with negative 3x. That 4 again times y. And this 5 times 4 is going to equal 20. This again is in standard form. So what we did was went from slope-intercept form to standard. Let's take a look at this equation. We've got a couple decimals involved here, so I'm curious to see how this is going to work out. So let's first get all of the x's and y's on one side. So I'm going to subtract 9.1x from both sides. And they asked us to get rid of the decimals. Or in other words, make sure we're using integers. Remember, integers are positive and negative whole numbers. Well, 9.1 is not a whole number. So my thought is, hey, if that's 9.1, that's the 10th spot, and this is 3.6, again, that's the 10th spot, is probably multiply everything by, yes, you guessed it, 10, and that will get rid of our decimals. Put my reminders over there. 10 times negative 9.1 is going to be negative 91 plus 10, y. 10 times 3.6 is going to be 36. And there we have eliminated all of the fractions or decimals and have it in integer coefficient. The last thing we're going to do today is graph the equations using intercepts. Well, here we have a standard form equation. One way to graph this is to go ahead and solve for y, but there's a little bit easier way of doing this, and I think this may have been relayed to some of you in class yesterday. Suppose I want to find the y-intercept. Well, to find the y-intercept, if you look at the graph, it's going to be where it crosses the y-axis, right? And you'll know that 0 is going to be your x value for any y-intercept. So if I plug in 0 for x, I'm going to have 3, 0 plus 5y equals 15. That's going to leave you with 5y equals 15. Y is going to equal 3. And that's going to be our first intercept. Next step is to go ahead and plug in 0 for y here. Whoops. Let's clear that up a little bit. Sorry, I had to jump forward here, but plugging in 0, you're going to get 5 for x, and I'm going to go down to 5 for x, and then we're going to go ahead and take our handy-dandy line and draw our linear function right there. See you guys tomorrow in class. Have a good weekend.